Hi, I am Anindita Das Bhattacharjee. This is a must-watch video to crack coding round for any MNC drive. In this video, I have explained and solved all the possible cases of prefix and postfix, increment and decrement operators. In order to solve any pre or post increment or decrement operator based evaluation, let's understand this chart first. And then I will solve different possible critical cases one by one on these operators. So in this chart, I have displayed the initial value of x, final value of x and y for both the pre and post increment and decrement operators. If you can understand the calculation shown in the chart, then it will be very easy for you to solve any problem with these operators. Now let's consider a problem where initial value of x is 4 and after complete evaluation, the result is also stored in the variable x. Before starting the evaluation, always remember pre and post increment unary operators has higher precedence than plus, that is binary operator. Therefore, first x plus plus and plus plus x will be evaluated. So initial value of x is 4. The assignment will then be 4 plus due to post increment. See the chart. X will have 4 assigned in it. Later, due to post plus plus symbol, value of x will be incremented by 1, that is 4 plus 1, 5. However, 5 is the intermediate value. Later, binary plus operator will be skipped and due to pre-increment operator, 5 will be incremented by 1, that is 6, which is now stored in x. Later, for the last x variable, the current value of x will be stored as 6. Therefore, 20 will be the final value inside the variable x, which is assigned in the chart under final value of x, which is 20. Let's understand pre and post increments in a code. Let's consider case 1 where we are asked to find output of the given code. In order to solve the problem, first step is to identify how many operators are being used in the code. In this case, we can see there are two operators, plus plus, which is a unary operator, and plus, which is a binary operator. Always remember, plus plus operator has higher precedence than plus operator. So unary operator, that is plus plus, will be executed first. Here as x is equal to 10, so the value will be incremented first and get assigned to x. So first plus plus x from left will be 11, second plus plus x will be 12, and the third will be 13. So the final value of x after unary operator evaluation is 13. Just looking at the problem, it seems like y will be equal to 11 plus 12 plus 13. However, always remember the last assigned value to x, that is the final value 13 in this case, will be assigned to all the plus plus x. So as per the code, the y will be calculated as 13 plus 13 plus 13, which is 39. So you might have a question, why the final value of x is considered for all the x? Because always remember the associativity of pre-increment operator is right to left, that is read from right to left. For that purpose, final value 13 is assigned to all the plus plus x from right to left. Similarly, for case 2, we can see the problem has unary and binary operator. So if you use the same trick directly, We know as unary operator are used 4 times, so the final value of x will be 14. Hence, y will be 4 times 14, that is 56. Be careful during competitive exam. At times on a similar given problem we might be asked to print the value of x instead of y. Now let's consider case 3, where the same unary and binary operators are used, but the unary operator is post-increment operator. Post-increment unary operator means the value will be assigned first to all the variables used with post-increment unary operator, that is x, and then it is incremented. That means the value of x is 10 will be assigned to both the x plus plus, that is y will be equal to 10 plus 10, that is 20. However, if you are asked to print the value of x after the execution, so the first x plus plus means 10 is assigned to x and incremented by 1, that is 11, and then the second x plus plus will be start from x equal to 11 plus 1, that is 12. So the final value of x is 12. This is the main difference between pre and post increment operators. In case of pre-increment operator, y was calculated after getting the final incremented value of x. But in case of post-increment, the given value of x is straight away assigned first. Now let's consider a problem which has both pre and post increment operators together. So plus plus x will be 10 plus 1, that is 11, which is as per the rule of pre-increment. We increment the value of x and then assign it to x. Now for the x plus plus, it will follow the method of post increment. That means the value of x will directly get assigned to it. But notice here, it is not the initial value of x. After evaluating plus plus x, the current value of x is 11, not 10. So y will be equal to 11 plus 11, and if we are asked to print the value of x, it will be the last value of x, that is 11 is assigned and then incremented by 1, which makes it 12. So now identify the given case, that is this one, and let me know the answer in the comment section. Let's consider the most critical post and prefix operated together in one expression. Always remember, whenever you are evaluating pre and post increment decrement operated together, the pre operators are executed before post operators. Therefore, associativity of pre-operators are considered first. And we already know the associativity of prefix is right to left and postfix is left to right. In the given problem, you can see it is a mixture of pre-post increment and decrement operators. But calculating the value of y will be very simple. Always remember two things. The prefix operator will execute first and the associativity of the prefix is right to left. Though this problem looks so complex, but using these two rules, the calculation is very straightforward. Here, the expression, or as a matter of fact, any expression as the prefix is executed first, so we calculate from right to left. And remember, we will consider only the prefix operations. It doesn't matter whether it is plus plus or minus minus. So here, rightmost plus plus x is 11. We will ignore the next postfix and consider only prefixes. So here we have minus minus x. So now x become 10. Then we have plus plus x, which makes x equal to 11. Then we skip next two postfix and we get minus minus x, which makes x equal to 10. There are no more prefix operations left, hence we get the final value of x as 10, and calculating y, we will assign the current value of x to all the x variables. Then after calculation y is equal to 40. So very interesting point to note here is no matter how many post and pre operations are there, we only consider prefix operations to get the value of y, and it is pretty straightforward. However, the complexity is more if we are asked to find the final value of x, because then we will have to calculate the postfix operations. So in this problem, only considering prefix operations, last updated value of x was 10, and we know associativity of postfix is left to right. So current value of x will be, start from left, skip y. The first postfix expression is x plus plus, which will become 10 plus plus, that is 11. Afterwards, next postfix operation is again x plus plus, which will become 11 plus plus, that is 12. And then we have x minus minus, that is 12 minus minus, which gives x as 11. And finally, we have x plus plus, that is 11 plus 1, 12. Therefore, final value of x is 12 for this given expression. So point to note here is evaluating y needs right to left movement, exploring only prefix operations. For current value of x needs right to left movement, exploring prefix operations along with left to right movement with postfix operations evaluation.